Hi, Chem 112 students. This is an explanation for lesson 20-2. And this is part 3 where we talk about the conjugate acids and base and their strength and how they're related. So an acid HA will lose its proton to form the conjugate base, A-. So these two things are conjugate pairs. This is the acid, this is the conjugate base. They differ only by a proton. At the same time, water is acting like a base. It's gaining a proton to make the hydronium ion. And therefore this is the conjugate acid of water. The difficulty of transferring that proton varies with the strength of the conjugate acid and the base. If the base holds onto that proton, it's not going to be a very good acid. So it's going to have the weaker the acid, the stronger the conjugate base. The base won't let go of the proton, so it's not a very good acid. If it's a stronger acid, the weaker the conjugate base will be. If it's a stronger acid, it's going to let go of that proton and not want it back. That means its conjugate base couldn't hold onto it. So we're going to determine 3 categories of acid and base strength. This is very, very important. You need to know what these categories are and how to assign these to a substance. So 3 categories of acid and base strength are, for a strong acid or base, it's going to dissociate completely in the forward direction. It's 100% ionized. If it's going to be a weak acid, that's going to dissociate partially in the forward direction. There's going to be an equilibrium. It's going to pass that proton back and forth between 2 bases. And then negligible is so very weak, we're not even going to call it weak. Those substances are spectator ions. They don't take part in the game, they just sit up at the sidelines and watch. So let's take a look at this. This is a table of a whole bunch of acids and bases. On the left you have your conjugate acid and an arrow. Over here you've got your conjugate base plus water, hydronium ion. So the acid has lost its proton, formed a conjugate base, and it gave its proton to the water to form that hydronium ion. At the top of the page, we have our strong acids. These are all 100% ionized in water. Every single one of them. Therefore, they're equal in strength in water. You can't get stronger than 100% ionized. You'd have to put them in a different solvent if you wanted to see a difference in the acid strength for these. So these 7 strong acids go 100% to the right. They're shifted to the right, they're shifted towards products as written. They're stronger acids than hydronium ion, which is the purple dividing line there. They're completely dissociated, and that acid never, ever, ever wants its proton back again. At the bottom of the table is the opposite case. These guys on the bottom right are 100% protonated in water. Those are the strong bases. And you can see that the arrow goes 100% to the left. They're shifted towards reactants all the way. 100% protonated in water. O2-, that's the oxide ion, immediately grabs a proton from anywhere that it can get it, such as hydronium, to give the hydroxide ion. And we don't think of hydroxide ion as a very good acid. In fact, the conjugates of these strong bases are called negligible acids. They're so weak, we're not even going to call them weak. They don't get the honor of being called weak. They're negligible acids. Hydroxide, hydrogen gas, methane gas, Those are so poor acids, we're not even going to call them weak. We're going to call them negligible or spectator ions. At the top right, those are the conjugates of our strong acids. They're so weak as bases, we're going to call them negligible. They don't even get to be called weak anymore. Negligible bases and negligible acids are conjugates of strong acids and bases. So if you think about HI, which is a very strong acid, 100% ionized, it goes all the way to form iodide ion and our proton, which is H3O+. That HI does not want that proton back ever again. That I- is such a weak base, it can't grab the proton from the H3O+. It doesn't go in the backward direction. Then everything else is kind of in the middle. They are all called weak. The conjugate of a weak acid is a weak base. They're all in the middle. In Chem 112, the word weak means that it's not at the top or bottom of this table. It's in the middle of the table. So the conjugate of a weak acid is a weak base. The conjugate of a weak base is a weak acid. And water is the dividing line between the strong and the weak. So we're going to distinguish between weak and negligible. Negligible is too weak to be called weak. So everything in the middle is weak acids and bases. So let's talk a little more about that. The conjugate of a strong acid in water is so poor, so pitiful of a base, it's not even going to be called weak. It's going to be called a spectator ion. So for example, if I have HX, or HX is HCl, or HI, or something like that, strong acid, I'm going to give up my proton and form X-. This conjugate, this is the conjugate base, is so poor and so weak that it's not even called weak. It's shifted to the right. X- has no affinity for that proton in water. So for example, what do all those ions in the box down there below have in common? They are all conjugate bases of strong acids. They're too weak to be called weak. We're not going to call them weak. They're negligible. They're spectator ions. They are not good bases. In fact, HSO4 is such a poor base, it's actually acidic. It's a negligible base, but it's a respectable acid. It can lose that last proton and form SO4 2-. All right, so what about the conjugates of strong bases? The conjugates of strong bases are also spectator ions. They are not good acids. They don't even get to be called weak. So for example, if I have B-, some base with an anion -1 charge, and I add a proton, give BH. If that's a strong base, then it's shifted to the right. That base won't go over that proton. It's got it and it's not going to let go. It's a very strong bond. And down below in the box, you've got some substances there. What do all those substances have in common? Well, this one we made by taking the OH- hydroxide and adding a proton. This one we made by taking CH3- methanide ion and adding a proton. This one we made by H-, adding a proton to make H2. And here we've got O2- plus H+ to make hydroxide ion. These are all conjugate acids of very strong bases. Those conjugate acids are too weak to be called weak. They have negligible acidity in water. They're spectator ions. They don't take part. These are negligible acids. You can also include in this group lithium cation, potassium cation, sodium cation. These are also negligible acids. They're spectator ions. And they are combined with strong bases when you make lithium hydroxide, potassium hydroxide, or sodium hydroxide. So lithium, sodium, and potassium ion are negligible acids also. So what we're going to say then is the conjugate of a weak base is a weak acid. The conjugate of a weak acid is a weak base. They're all in the middle. These compounds are intermediate. They're not strong at the top. They're not negligible at the bottom. They're in the middle. They're called weak. That's very important. You need to know that. Here's our table again. And I'm just trying to highlight the middle of the table. All these things in the middle are weak acids and weak bases. That's not to say they're all the same strength. They can be weaker or stronger within their category. Ones at the top on the left are stronger weak acids. So these guys. And these are weaker weak acids. Up here we've got our stronger weak bases down here and our weaker weak bases. But they're all just called weak. These are the weak acids and bases. They are intermediate. A strong acid would be good at donating a proton. A strong base would be good at accepting a proton. Water is at the borderline, at the purple lines. It's kind of the solvent. And in the middle are the weak acids and bases.